Okay, today this is the second open session for week 9. So I think deadline of the week 9 is tomorrow. So if you have any doubt or any query in the week 9, you can ask, or any other query. So for C programming, there is no quiz too, but after that, just after 1 week or 1 2 weeks, you have OPP exam, and the syllabus of the OPP exam will be till week 10. Okay, so file will also be included in your OPP exam. So just complete this week 10 content before the this 10th December. Okay, so that is also a part of this OPP exam. Okay, so anyone any query week 9, and have you started the week 10?
Sir,
Yeah, Chitra.
GRP matrix assignment, sir. Answer does not come, sir.
GRP week 9.
Yes, sir.
Okay,
Matrix assignment, sir.
okay, let me share my screen and talk.
Diagonal sum and diagonal. Um,
Mhm. So you're talking about week 9 GRPA with GRPA?
GRP, sir.
GRP number?
I don't know the number. Matrix sum, so diagonal sum.
Let me check then. So this is linked list array polynomial. Count from 2D array. Yeah, this one.
Yes, sir.
Hmm. So here two-dimensional matrix is given, and diagonal sum is asking. Okay. So how you are doing for this problem? Any idea?
Uh,
Any logic?
yes, sir. Matrix I, comma I.
Sorry. Yeah.
Print matrix I, comma I, sir. Matrix array I and J, sir.
So we are just adding the diagonal sum.
Yes, sir.
Okay. So you can simply traverse this matrix. You can traverse this matrix by two loop. If you see the code, so you can also use this code structure. Let me just
Yes,
zoom it.
sir.
Okay, so how we can traverse the matrix? Okay, so here actually we are reading the value from the input. Sorry, let me check int, and then yeah, we are reading the element and we are storing into the matrix onto the that ith row and jth column. So same things what you can do, you can just use the same nested loop structure, and when I and j value both are same, so if you look
Yes,
the
sir.
input, okay, if you look the input, so 0, this first line is representing the 0th row, second first rows, then second row. Okay, so 0th row, 1th index row, and second index row, and similarly for the column, 0th column, first index column, and second index column. So for the diagonal value, during the running of this nested loop of I and j, if you can see, this diagonal value is coming at 0 0 place, 0th row, 0 column. This is coming at one
One
index
comma
row.
one comma.
Yeah, 1 comma 1. This is coming at 2
Two
comma 2.
comma two, sir.
Yeah, so simply just take one variable of total, and you can just run this loop. Okay, just go through this type of loop, and just take one condition: if I equal to j, then add that value into the total sum. Okay, so this is the requirement of this program only. Okay, what question is asking that diagonal sum you have to retain that accept an integer n and a 2D array of integer of size n into n. Okay, so you can see the what parameter we are passing inside the function. So n size we are passing and matrix we are passing. Okay, so you can simply write the definition. This is graded, so I cannot write the code for this, but I hope logic is clear. You can try simply. I've explained the logic. Okay, so first write the function definition, and after that just start the loop from I0 to uh, n minus 1. Okay, and second loop start with j equal to 0 to n minus 1, and inside this loop just check the condition. If I equal to j, then just take one variable like total here, total equal to 0, and then add all these values. So total equal to matrix.
I comma I.
So this two index. Okay, so I comma j, like this. Okay,
Okay, sir.
yeah.
Okay.
So this is the structure, and return the value what according to the problem statement. So if so, the function
Last
return
one,
the
sir.
sum of the main diagonal. Yeah, return the sum.
Okay, sir.
Okay, so this is the things for the problem.
Last one, sir.
Last one.
Last one, sir.
Okay, display matrix. Huh.
Yes, sir. This one also.
So okay, so here similarly you have two-dimensional matrix where the row and column is there, but in this problem, what is asking that there is another input that is single character input R and C. Okay, if input is R. Okay, so let me just explain the problem. One second. Sorry. So what is given here is if input character is R, elements should be print row wise. If input character is C, elements should be print column wise. So what is this row wise and column wise means? So if we are taking some input, okay, R and C. So two value we are taking only taking. So R and C. So R means row wise, C means column wise. So that means we have one input in we have one matrix in the input, and if we are getting this character R, so you have to traverse the element row wise like this: first row, then second row, then third row. So output this element should be print like this: 1 2 3 4 5 6 7 8 9. Okay, if input character is given C, so you have to read the elements column wise like this: first column, then second, then third, like. Okay, so in this way the order will come like 1 4 7, then 2 5 8 3 6 9. Okay, so this order should be come in the output according to the input character, or one input list is given. So you can use the index accordingly. So you can just use one if else condition. So if that input character, so first thing let me check what is given. So according to the problem, you need to write a function display matrix that accept an integer n, integer m. Okay, so size is different here. Okay, so number of rows and number of columns are different. An integer 2D array representing the matrix of size n into m. Okay, and a character as parameters. These information is given, so you can see in the suffix code also. If you see the suffix code, you can verify the things. So display elements, we are calling this function here. One, we are passing the number of rows, number of columns, and matrix. Okay, so this is 2D array. So this matrix you can see, this is the matrix which we have created of size this one. Okay, and finally this type. Okay, so type is singular. Type is a character only. You can see that this type data type is character. So we are just needing one character for this. That could be R or maybe that C. So this information we are passing. So you need to write the definition of this function display. Just assign the parameters accordingly. So just this is an integer value. This is also integer value. This is a 2D matrix. Just assign a one matrix for this, and you can pass the size n into m like this, and type. Okay, so just take these four parameters. After that, just make the logic for this. So how you can print this row wise and column wise. So row wise is simple. If character is r, so what you can do, so first loop you can run like I. Suppose if you're taking, so at least you have to run two nested loop for to print, read this or print this. Okay, 1 second. Yeah, Raja.
Sorry, sir, not related with this one. After completing this, the similar guidelines I'm expecting for the graded assignment 2 also.
Uh, Question two.
This one is fifth question, right? The
Yes,
second
yes,
question
yes.
also.
Yeah. Okay, 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 sir.
Yeah, thank you.
Yes, sir, I'm too requesting some help for the two graded questions which has a malloc function related to malloc questions.
Malloc question. Yeah, dynamic
Yes,
memory allocation. Okay, okay. We
yes,
will
sir.
discuss.
In that, there's something related to functions with dealing with structure like that. So I have very much like not much getting the concepts through it.
Okay, that malloc related concept you want to discuss.
Yes, sir.
Okay, okay, sure. So after completing these two questions, I will take. Okay,
Yeah, sir. Please,
that
sir. Yes, sir.
malloc one. Okay, okay. So yeah. So yeah, regarding this, how we can just traverse this two-dimensional matrix according to row wise and column wise. So we can take two nested loop like this: I 0 to 1, 0 to n-1. Okay, so size of the row is like n, and column are m. Okay, here sizes are different, so you have to just decide that which variable loop will range you will define accordingly. So I 0 to n-1. So suppose we are running this loop as a row, and inside this we are running another loop like for the column. So 0 to m-1 this time. Okay. Now we want to traverse all the first element. Suppose input character is r, then we have to traverse row wise. So that means, uh, okay, so 0 0. Okay, so this is representing. Okay, so this first I value is representing row. Okay, row index. So this for single value of I, this j loop is representing for column. Okay, so this is representing for I, and this is representing for column. So in this case, you can simply print the element like this. If matrix name is m, and you can simply take I comma j. So in this way the matrix will be printed row wise simply. Okay, so here for I equal to 0, so this j loop will run completely from 0 to m-1. So this is representing the columns. So here in the each iteration of I, so I equal to 0, j loop will run 0, then j will run for 1, j will run for 2, like this. Okay, for this input I'm just talking about. So I equal to, so 0 row and all three columns will be printed in one line. So this 1, 2, 3 element will be printed. Then we will come out to the above loop, and this value will be increases to 0 to 1. So that means I equal to 1. That means we have moved to the second row. Then same things, j equal to 0, j equal to 1, j equal to 2. This loop will run again. So that means we are printing the second row. So 4, 4, 5, 6, like this. Okay, similarly then I equal to 2, then we will print the next loop, 7, 8, 9. Okay, so in that way you can run one loop. In the second condition, where if you are getting this c, so that means you need to print the value according to column wise. So what you can do, so first in this case you can run, you can take one loop, first loop for the column. Okay, like I equal to 0 to m-1, and inside this take column for take loop for a row. that because you want to print all the rows first in this manner. So that is j equal to 0 to n minus 1. Okay, so this time we are taking this j for the row. So and inside the matrix, so just pass the parameter in that way. So like print. Okay, I'm not writing the complete syntax. You can just make accordingly correct. So just m and first parameter. So here this is representing column. So we want, because we want to print column first. So this I will remain in the second place. Okay, so I will remain here. 1 second. Okay, yeah. This I will just put this I in the second index and put j in the first index. So what will happen for I equal to 0? So 0 is representing the 0th column. So this value will come here, 0, and this value will run from 0 to n minus 1. So that means you will get the value in matrix like this. So m, so for inside inner loop, okay, 0 to n minus 1. So this 0 and 0. This will print first. In next iteration, this m, this will become 1 and this will remain 0. Okay, and next m2 and this will remain 0. So that means this j value is moving from 0 to n minus 1. Okay, that means all row. First we are printing all row. So 0th row, first row and second row. Column is same. You can see that in the first iteration column is same, 0 0 0. So this part will be printed. Next iteration, when the jth loop is completed, then we this I value will be increases. So this is representing column, so 0 to 1. That means we will move to the first column, one index column. Then this second index will become 1, and this j loop will run similarly. So 0, then this will become 1. Okay, so 1 and 1. All three places, this will look like this. 1. Similarly, next. So in this manner, you can just put the your nested loop in this manner. So you will get the value column wise in the output. Okay. So write the code accordingly. So this is created. So I'm not writing the solution code for this. So Chitra, is it clear?
Yes, sir.
Okay. Yeah. So someone is asked GRP2, 3, RP2. This is week 9. Okay. Point poly 9. Next. Okay. With 3 points there, I think this is discussed. Okay, let me just read the question first. So design a program that finds the Manhattan distance along a polyline defined a series of points in a two-dimensional space. Each point on the polyline is represented by its two coordinate x and y. Okay, so first structure is that means structure definitions are given. That means two structures are required for this program, points. Okay, so this points is a one structure and it contains two attribute x and y. Another structure we have polyline, a structure representing a polyline. It contains a pointer points. Okay, that point to the first point. Okay, in the polyline. For empty line, it will point a null. Okay, that I'll explain this later. And function we need to require this void add point. Okay, this is the one add point. Add a new point with the coordinate xy to the end of the polyline. Okay, then another function we have this. Compute the total Manhattan distance of the polyline, which is the sum of the absolute difference of x and y coordinate between the consecutive points. Okay, void print line polyline. Okay, and print the points of the polyline in order indicating the direction of the polyline. Okay, So these three function we need to require, and some template is, I think, it is given. So you have to just fill this function. So here definition is already given. What you have, three function definition, what you are getting, and okay, so only two function required. Okay, so this Manhattan distance and this print line is already there. Okay. Okay, so one structure is also given. So structure definition is also given. So we have two structure point. So here this contain only two value, x and y. Another structure point, that is, okay, so this is structure point next. What is this? Okay. So this is the same thing. Okay, this is completing here, and second structure is starting here. So that point contain the point stack. Okay, point. So what we are doing, actually, we are creating a list here using the dynamic memory allocation, and in this list, I'm just drawing this thing at point, and let me just the function. So in the main function, what we are doing, we are taking x, y, read next, into read next. Okay, so polyline null while scanning this in, read next, read next. Okay, print line. So what program structure is, what we are doing, we are reading input, and we are reading this input. So I'm just giving one simple example first, then we will discuss this problem. So what we are doing, we are just reading some input, like suppose we have one variable int, so like this, int a. Okay, and we have some variable, or I can take one struct like this, so struct, and I'm just making this as a node. Okay, and inside this I'm taking two variable, int a, and another is like struct stick next. One term is missing. Let me clear this. Struct node stick next. Okay, and these are two. Okay, suppose we have this struct node, this contain one value, and this is also contain one field that is a pointer of the similar type of this struct node. Okay, and what we want to do, actually, we have created one pointer. So suppose I am creating one pointer like struct start. Okay, struct node, and that name is given start. So this is also a one pointer. Okay, similar to this next, this is also a one pointer, and that is also contain the reference of the node of type this struct. Okay, similar to this struct. So I'm just drawing the logical diagram for this. Suppose I create the one memory allocation for this struct. So according to the dynamic memory allocation concept, what we can do, to store the value in this struct node, we can allocate the memory at runtime. Runtime means, so here in the problem statement, you can see that we are taking the input in the while loop. So while loop means until we are getting the input, we will add in our memory, and once that input is finished, then we will stop the process. Okay, so we initially we don't know how many elements we have to store. Okay, our while loop is running, it is giving some input value to add in our database memory, and we don't know how many input it will give continuously. Okay, so in this case, if we don't know how many elements will be stored in our memory initially, and we are reading continuously some input from the user, and in that case, what we can do, we can use the dynamic memory allocation. And in dynamic memory allocation, in the every input, if we are receiving some input, suppose we are getting this input series like 10, 20, 30, 40, 50, 60, like this. Okay. So inside the while loop, we are just receiving this 10 input first, then sec 20, then 30, then 40, then 50, then 60, and after that empty. Okay. So initially we don't know how many inputs we will receive from the user. So we cannot initialize array because we don't know the size. Okay. So how we will store that type of information if where the size we don't know, and that size is dependent on the input user. Okay. So we cannot initialize array, we cannot give the size to the array. So in this case we can allocate the dynamic memory. We will receive one element, we will allocate the memory for that, and we will store. Okay. After that we will receive the second element, then we will store that element, and we will just arrange some logical relationships so we can access that all elements in some way. So what we can do, this first struct node I have created. Okay. So this structure is created where the one variable contains one integer value. Okay. Integer value. So that means if we draw the logical structure for this, so this area total, this complete structure, okay, this contain two field, one for a and second is next. Okay.
Sir, can you repeat it again, please?
Yeah. So this structure, I am just drawing the logical diagram for this in the memory way. Okay. So this complete structure is actually a memory block where the two space we have in one block. Okay. If we are creating a node, suppose if you are creating a node for this, let me just write like this: struct node a. Okay. So I am just creating one variable a of type this struct node. Okay. So this struct node, this is the type of this variable a. So that means we are allocating some memory. That means we want to some store two value for this a. So this a is representing like this, and two memory block will be provided. And in this two memory block, first block we will store some integer value. Okay. So this a is a integer, and this next is a pointer. Okay. So this star, you can see that it is a stick, it is written before that. So this next is a pointer of the same type of node. So this, you can see that the type of this a is struct node, and this next is also a pointer that will also contain the reference of similar type of node. Like suppose we have another node of the same structure type b. Okay. I'm writing two variable here. Okay. Now here a and b both are the type of struct node. So this next field will contain the address of similar type of node, struct node. Okay. This. So in every structure we have these two field, one is the integer field and another is a pointer field. Okay. Next, and this pointer that will contain the reference of the similar type of the node. So in this manner, what we can do, we can just link all the memories so we can access later. What we can do first, we will allocate. So first we will create some variable pointer. Okay. So I have just mentioned the statement for this, like struct node asterisk start. Okay. This is one pointer. That means this pointer will contain the reference of first node in the list. First node. Okay. After that, inside this, what we will do, we will just allocate the memory. So like this start. Okay. So we will allocate the memory like this. So struct node asterisk and malloc and size of, because we don't know what is the total size of this struct. Okay. So we don't know what is the, so we know that integer a size is 4, but we don't know what is the total size of this pointer, what is the size of this pointer. So what we can do, we can simply calculate the size of this complete struct. So we can simply write this struct node. Okay. So if we will write this line in the during the program, so at the runtime, that this function will provide one memory to start, and that memory block address will be stored in our start pointer. So this is also a pointer of the struct type. So that means this is creating this is allocating one memory block of this type, okay, struct type, where we have two memory space, one for a and second for next, okay. And this memory block address we are containing with start, okay. Some memory block address, suppose this memory block address is 1002 like this, okay. And this 1002 address, this is the address of this memory block starting address, okay. And that is we are storing inside this start pointer. This is the first node we are allocating, okay. And when we are allocating this memory at the running time, and we are reading the input from the user, so this 10 value, suppose we are getting reading first, so this, after reading this 10 value, we will create one node. We will just assign some memory for this node, and we will store this 10 value here, okay. Now this is the first node in our list, so this will contain null because there is no element after that in the first loop. Once the second node, so after reading this, we are storing this 10 value in our memory space, and after that we will store the next value. In the next iteration of the while loop, we will read, oh, we are getting the second value 20. Then that means we want to store this 20 in our memory. So what we can do, we will just allocate another memory, okay. So same things we will repeat. We will create one node, okay. So this is for the start things, and after that we will create some node like this node equal to same line, okay. And we will create one node, and this node we will link like this, okay. So the node will be create similar for the first node, and we will store 20 here. What we will do, we will store the reference of the second node in the field of the next of the first node. Suppose this address of the second node is like this 2020, okay, like this, okay, 2020 in the memory. So that address we will store in our previous node next field. So this is a one pointer, okay. So that will contain the address
Sir,
of next node.
am I correct? I will just repeat what you said. Just see whether it is correct. So we will be allocating some amount of memory,
Yes.
and the last variable have a null variable in its pointer, right?
Yeah, this is a pointer. If there is no node after that, okay, if there is
Yes,
no
sir.
node after that, then we will store null. If any node
So
we
yes,
want
sir.
to store after that, we will store the address of that node.
Yes, sir. The address of the nth variable will be stored in the pointer of the n minus one variable, right?
N minus one, not n1, int, not the, we are storing the address of this complete block, not the int variable, okay. First thing, okay, because we are
Yes.
creating
Okay.
the node of the structure.
Sir.
We are creating memory allocation for the complete structure, which have two fields.
Yes, sir.
Okay, so the address is also, starting address is also pointing to the complete memory allocation for the node,
Okay.
okay.
Yes, sir.
And that
Yes, sir.
address we will store here like this 2020, okay. So what will happen, the first node address is available at the pointer start, okay. Second node address is stored at this place, okay, 2020. Suppose next node is coming like 30, next value we are coming 30, we will repeat the process. We will create one new memory allocation, okay, and we will store 30 in the first field, and we will store the address of this new node into here, previous, okay, previous location. So we will repeat this process, and we will link the memory allocation by the address. So what we are doing, we are just linking the elements by the address. We are storing the address of each element into the previous element memory place, that pointer place, okay. So in this manner, what you will get, the list of like this structure. So this is a start, okay, and start will point to the first node, and that will contain 10. Then second node, that is contain 20, that is like 30, okay. And that will 40. So we have total 5 value in the input. So 50. uh, okay, so and then 60 also. Okay, yeah, 60. Okay, and after that there is no node, then we will store null here. Okay, so this means you can see that this is, I'm just representing as a to this representation, but this is actually a one memory allocation which contain two value. First is the this integer a value, and this is a pointer. Next, in each memory block, this is the two value we are and we are creating this memory allocation for one the structure. So this each node is representing one structure which is containing two value. Okay, similar this one. Okay, like, and what we are doing after getting one value, we are creating one structure, we are storing the data, and then after that we are for the next value we are creating the next memory allocation, and we are adding by the address, we are linking by the address. Okay, so why we are linking? Because this memory allocation is happen in the different place of the memory. In the different place of the memory, this memory allocation is happening. So suppose the first block address is like this 1020, we are not sure that the second address is continuous of this memory block. Okay, so it may be like 2040, and it may be like 504050, like this. Okay, so I'm just taking some example of the address. Okay, so this memory allocation may be happening at any place in the memory. So if we want to access these element in our program again, so for what we are doing, we are storing these value in our program. So later maybe we need to require some operation on these elements. So in that case, we have to figure out some way of the accessing the element. So this is the way you can use, you can link the elements by the address, and just store the address of first element in this start pointer. Later, if you need to read all the elements, what element you have stored in this list, you what you can do, you can just read the start. What is the start value? Okay, so start, you can read the first element address. Okay, and you can get the first value. After reaching at the first memory location, you can read the what is data is stored in this 10. Okay, read the just next value, what next value is stored with this 10. Okay, so this is a address, this is a address of the next element. So after reading the address, you can directly move to that address and read the second value, that 20 you can access. Okay, then read what is the value, what is the address value in this field. So the address value is pointing to the next location. So that after getting the location, you can move that location and you can read the next value, so 30. Okay, similar, read the address, then move to the next, so 40. Then you can access all the elements which you have stored. Okay, and you can perform any operation on this data. So in this way you can store any number of elements. If you don't know what is the if you don't know the size of the input initially, so you can store all the element by linking the address. So this is called as a list, and we are linking this element, so we generally says that as a linked list. Okay, so we are linking all the elements by uh, some address, by the address. Okay, and in this way we will process this. So we are 40 reading, then we are reading 50, 50 we will get. So we will repeat this process. So one at the one time we will get this null value. So this null value is representing that there is no element after that. Okay, so we will stop this process. So that means we can access all the elements if we have stored element in this structure in this manner. Okay, so you can access all the element. So similar things you need to apply the in the given problem. So here this you can see that so we are getting point here. Okay, so what value is the representative one? Let me check here. int xy read next polynomial name this scanf percent ld 1. Okay, 2 point. Okay, so you can see that how we are reading this input in the program. So this first value, okay, so this first value is 1. 1 is representing that we have one input to read. Okay, if we are getting this 1, that means we have one next input to read. So we will read. So let me copy this. Okay, so if you see this input, so first value is representing, indicating that we have to read next to point. Okay, so this is representing x, this is representing y. So that means we are reading 5 and 10 first. After that we are reading again 1, so it is indicating we have one more input to read. Okay, so this means we have one more input, that is the next point. So 8 and 15. Okay, now once again 1, this is next point we have to read. Okay, so 12 and 20. So this is the input way. So we don't know initially how many points we will read from the input. So user is just giving this one value. Okay, that means one, that he want that they want to enter one more point. Okay, this is one is indicating that they want to enter one more point information. Okay, so one here is here, one is here, and once he input 0, that means this is the there's no input for the next thing. Okay, so in this manner user giving the input, so you don't know initially how many points user will input in the program. So in this case what you can do, you can, so in this problem structure is given for the point. Okay, so one structure is given for the point. What you can do, you can create a memory allocation for the structure, so that contain 3 fields. Okay, so one, this is the integer, so int x, int y, and this is a pointer next. Okay, so just read the input 1. If this input is 1, read two value x and y, and store this value here. So 5 and 10, because this is a first node, so that means one pointer you have to take in that will represent the address of first point address. Okay, so suppose start, and this is a field that will contain the reference of the similar type of structure. Okay, memory allocation. So this is the first. After getting next one, that means you need to add one more point information. So you will allocate one another memory allocation for the same structure, so that have same 3 field, x, y, and next, like this. Okay, and you will store this 8 and 12 here, 8 and 12, and that will just link by this. Okay, store the address of this second node in the field of the next in the first node, like this. Okay, so that will be linked. Again you have one, so you will create one more node, 3 field. Okay, so first store this 12 here and 20 here, and after that there is no node, so store null in this field and link the address. Okay, so just store the address of third node into the second node next field, so that will link like this. So all point information is stored in a list in this form. Later what you can do, so you can simply read all the elements. So this is the memory, we have stored the points in our memory of using the dynamic memory allocation, and you can see that same things we are printing in the output. Okay, so 5, 10, so we are just reading this, we are starting from the start pointer and we are reading this value 5 and 10. Okay, so this is just a representation of the printing. So we are printing this information 5 comma 10. Okay, next value, this is 8 comma 12. Okay, next value 12 comma 30, 20, and there's no element, so this contain null value, so that means we will print and here, and so this is the first things you have to create this type of list in the code. And another thing is given like the maximum distance, that things. Okay, so that is just a absolute difference of the two consecutive points, like, so the formula is given, so just apply that things. So in the first function add point, okay, so here add a new point with coordinate x comma y to the end of the polynomial. So after reading the points, just add into the last in our uh, polynomial list. Okay, so these things you have to perform in this code. So yeah. So what we are doing, you can see in this code, this is the reading statement. We are getting 1 or 0 using this scanf. If this value is 1, okay, that means we will enter inside the loop and we will read two value x and y. And we are calling this add point as line comma x and y. So this line is representing just a one uh, list. So this contains the address. Initially this is empty, so this will contain the first node address, and we will add each node in the end. After reading the point, we will create a one new mode and we will add into the end. So in this way one list will be created, and after that we are printing this line. Okay, so the function of the print line you can see here, this is given. We are reading the add a pointer of the first node, and after that we are simply running the loop. Current, we are just setting this current equal to the first node. Okay, what is the first point, and we are repeating this process until we are getting current equal to null. Okay, so this null is representing of the last node next field value. Okay, so every time we are printing x and y value, and we are printing this arrow something, and we are moving to the current equal to current dot next. Okay, every time we are shifting, we are reading the address of the next node and we are printing the value. We are reading the
Sir,
next.
can you just recall the arrow pointer, like arrow operator? I'm not familiar with it.
This one. Okay, so this
Yes,
is
arrow.
you're talking about this one, no? This arrow.
Yes, sir. Yes, sir. Yes, sir.
Yeah, so this is actually this is the way to read the access this struct member actually. Okay, if we have struct member, so here we have struct 3 member in this code. So if you see the struct of this, so first struct you can see here, this is the struct. Okay, so this struct name is point. Okay, it contains two integer x and y, and third is a pointer. Okay, and pointer to the similar type of same structure of this point. Okay, so you can see the type of this next is same struct point. Okay, so what we are doing, if we want to access the value of struct, and if you have pointer, so you have to use this arrow symbol. So arrow symbol is not something like, okay, so I'm just creating one. Okay, so pointer, and so this is struct. Okay, so int x, int y, and struct point and asterisk next. So this is the structure of the problem. Okay, so at any time if you have the address of this structure, okay, so we are storing this three field x, y, and next. Okay, so this is the structure memory allocation. Okay, so we are storing the data in this structure, and if you have the pointer of this structure, okay, suppose if you have the address of this structure like struct point of like x. Okay, not x, this temp, I'm just giving. So this is a variable name, this is a pointer, and of type this struct point. Okay, and we are storing the address of one node inside this temp. So temp is containing the address of this structure node memory allocation. So how you will access the element or member of this struct? If you want to read the value of x, what is the value of y, what is the value of next? So how you will read? So if you have the pointer, then you have to write like this, temp, then this is the simple minus sign and one greater than sign. Okay, this is not a arrow symbol on the keyboard, this is just a combination of two character, it's minus and greater than. Okay, and then you have to write x. and you can print this like, okay, print f like percentile d and comma this. Okay, if you are writing like this, temp this minus and then this greater than x, so that means you are just reading the value of this x. What, suppose here this is 10, this is 20, and this is some address. So if you are printing this like this, so that value 10 will be printed in the output. Okay, so this arrow structure is required if you are accessing the member using the pointer of struct. Okay, if you have the variable of the struct, okay, suppose if we are creating the variable of the struct like this, struct point and that x, this like a. Okay, so here this is a one variable of this structure a, and if we want to access the element or member of this struct a, then we will use this dot operator, a dot x. So this is not a pointer here, this is just a copy, or this is just a variable of the struct point. Okay, so then you can access the element like this, a dot x, a dot y, a dot next. Okay, so if you have the variable of the struct, you can using the dot operator. If you have the pointer of the struct, then you have to use this arrow symbol to access the member. So same things we are using here. So in this print statement, you can see that we have created the list, that linked list, and we are just starting from this current. Okay, so we have just set this current equal to p dot point. So this is representing the first node. Okay, after that we are just accessing the current dot x and current dot y. Sorry, this arrow operator. Okay, because this current is representing pointer of points. Okay, so we are reading this x and y value, and we are shifting this current equal to current next, so that current next field value will be assigned to the current. Okay, so this current next is representing a address of the next node, so that address is assigned to the current. So that means our current is now moved to the next node. Then we will read the x and y value again, and we will shift next node. So this will we will repeat this until so at some point we will reach at the last node, so that contain the null value in the next field. So at that time this condition will be not satisfied because our current will be stored the null, and we will stop this process. Okay, so we are reading our data in this manner in the list, and you have to create the list in this function. So this line is actually contain the first node, and after that you every time you have to traverse the list and you have to reach at the last node, and then you have to add the next node.
Sir,
So I think
now there's another one structure like it contains the pointer of the point variable. Can you explain about this?
pointer of the pointer variable.
Yes, sir. In point line number 9, can see
Line,
that there's a
uh,
pointer of a variable point, which is a
yes,
structure.
yes. No, no.
What is it?
So here
Yes,
actually
sir.
what is given here. So this is one structure. Okay, this is the another structure, and the name of this structure is a polyline. Inside this we have one member, and the member name is points, and this is a pointer of type point structure of this is the point structure. So here actually this is representing a pointer which contain the address of first node of the list. Because of that we are creating this. Okay, so this is just a name points. You can give any name like start, where the node is starting in our memory.
So
Okay,
it is just to address store the address of the first variable.
first points in our
Okay,
list.
sir.
Okay,
Yes,
so
sir.
this structure is used
So why don't we just call it as a point star points? Why do we call it as polyline?
This is just a given one problem definition. Okay, so you can change according to the problem statement. We are following this naming.
Okay, sir.
Okay,
Yes, sir.
but this structure purpose is to store only address of the first variable. These points.
Okay, sir. Yes, sir. Got it.
So I think similar type of problem is also given in the practice assignment. If you look this, I think structure is also mentioned. One second. One diagram is also mentioned that. Two-dimensional array. Okay, let me check. Okay, so before just you can see this problem also. This is a similar problem. Okay, and structure of the list is also given. You can see here. So if you understand this problem, you can also solve the next that problem also. Okay, so this is also similar. What we are doing here, we have one structure. Okay, so in this problem also we have one structure of student. Okay, and that means we want to store the name of student. So here you can see that we are reading the data in similar way. If we are reading the data, then we are asking, do you want to insert more student information? If this value is 1, then we will input one more student name. Okay, if this value is 1, then we are input one more student name. So our input is based on this value 1 and 0. Okay, so initially we don't know how many student name we will input, we will take from the user. So if that value is 1, we are reading the next value. Okay, if that value is 0, we will stop this process. So we cannot we cannot assign any array for this because we don't know the size of the input here. So in this case, so this student 1, student 2, this is just a student name information. What is the name of student? So to store this data, we have one structure. You can see that structure, the struct name is student, and each structure we have one field name. Okay, the maximum length of the name is 50, and another pointer is just a pointer. Okay, pointer of this structure, same structure. This name is next. So this is also the same. Now the structure is also given in the problem. You can see that we have one start pointer. So this start is also a one pointer of the same type student. Okay, that will store the address of the first student name, where the first student name is stored. After that, we will create the new memory allocation for the same struct, and we will link by the address. Okay, so student 1, student 2, student 3. In this manner, we will add all the student name by the address. We will store the address of the student in the previous student next field. In this manner, we will link all the names. So later, if we want to access all the student name, we can simply start from the first node by reading the address of start, and after that we will just read the address of the next field. What is the address of the next field? Then we will move to the next node. Okay, then we will read the next field, then we will move to the next node. Okay, and we will print simply this data. So here you can see the code things. So we are asking to create this student list. Okay, and if you see the while loop, okay, here we are simply printing this list. After creating the list, so we are calling this function. So first we are calling this function student list. This function should print a address of the first node. That address we will store inside the head. After that, we are just running this while loop. While head does not equal to none, we are simply printing the name, and we are moving this head equal to head to next. Okay, so that means we are reading the address of the next field, and we are assigning to the head value. That means this address is shifting, and every time we are printing the name of the each field. So in this manner, we can access all the elements which we have stored in the list. And here you have to create the function. So we can discuss the solution for this, how we can write the solution for this. This is also graded, sorry. We cannot write the code for this. But similar problem we have in the PPA. So I think we can discuss if employee list. Not this one. Yeah, this one. This is also a similar problem. Okay, so here we are storing two information: employee name and what is the salary of this employee. Okay, and same things. We are reading the input one, 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 and after getting zero, so we will stop this process. So that part is actually basically okay. So main function. Yeah, that you have to perform all the things. Here we are calling simply this employee list function, and you have to read the data and you have to create the list, and structure is given in this problem. You can see the structure name and that is given. So in this problem we can simply write the solution. What you can do, yeah, okay. So employee list, so the function name is already given here, so no need to write the definition of the name of the function things, anything. So in this one second. First thing, we are reading the input, and every time we are asking that what is the user want to print more input. If yes, then print that input is 1. Okay, otherwise if input is 0, so that means we will stop the process. So that means we have to use some place do while loop here. So do, and inside this, and then we will perform the while condition. While, okay, first we will read the student information. So that we have two field here, and what the field we require is, first we will create the this struct for the student. Okay, so struct, and the struct name is employee, sorry, employee. Okay, and that so okay, so first we want to store the address of the first node in one variable. So we are giving some name like first. This is one pointer first, and initially we are assigning this equal to null. So that is null, because initially we have no data. So because of that we are assigning this. Another field, what we can do, okay, so later we will initialize if we require. So now this is the one information we will create, and another field is choice. So according for the user, int choice. Okay, so this is one data is required, and this choice we will use here. So every time what we will just read one value inside the do loop, and it's using the scanf %ld. Okay, and we will read this choice values. Choice, and we will mention this condition here, choice equal to 1. Okay, yeah. So what is this structure is actually, this is the do while loop. Okay, and inside this do while loop, after we will perform some operation here, and after that we will, yes,
Choice don't have ampersand.
yeah, it have, yeah, one second, thanks. Okay, so what we will do, we will just perform some operation here inside inside the do block, and after that we will read some input for the choice. If this choice equal to 1, that means we want to read one more input from the user. Okay, then we will repeat this do again. Okay, and then once again we will read the employee information, okay, name and that salary, and we will add into the list, and after that we will read one more choice. If this is 1, we will repeat the same thing. If this choice is not equal to 1, then this loop will terminate. Sorry. Okay, so in this case, so in the every iteration, because we want to add one employee information in our list, so we will create one struct that will memory allocation. We will just create some memory allocation here. So struct that employee, okay, and that will give some name for this variable like node, okay. So asterisk and node. So this is one variable I have created, just this is one pointer, and we will allocate the memory for this. So the memory allocation function syntax is, well, first we will read the typecast here. So struct and that employee, we want to store the address of this struct type. So that we will write first here, then after that we will write malloc, and what is the size of this struct. Okay, so we will just write the function of the size of, and this same struct and employee. Okay, so this is the syntax to allocate the memory at the runtime. So this function will allocate one memory block. That memory block that is provided for the struct type. Okay, this struct employee type, that will contain three field. The memory allocation for three field. One is the this uh, name. Okay, this is a string, and that salary. Okay, and that address. Okay, so every time what we will do, we will just create the memory allocation. That memory allocation address will come this in this variable node. Okay, after memory allocation, that address will be stored in this node, and we will store this address. We will just link this node. Okay, first we will read the name and that things also. Okay, so what we will do, first we will check if this node is the first node. Okay, so first node is representing that if our first value, if first value equal to null, that means our node will be, we will store the address of our node in the first field. Okay, so what we will do here, so if we will check here, so if first equal to null, so this condition is representing we are adding first node if this is satisfied. Okay, so what we will do, we will just like this. So first equal to node. Okay, so, yeah, and so this is things. Okay, else, in the else part. Okay, so this is tab next. We have to read. Okay, what we can do, because we have to add each node every time in the last position. Okay, so what we can do, we can also store the address of last node in one some variable. So this first is contain the address of first node only. So this condition will be satisfied only one time, and at that time we will store the address of first field. So one more information we need here is to store the last variable. One second. Oh, some battery issues there. Okay. So we will create one more pointer for this. So that last asterisk, last, initially we are storing like null, because we want to keep maintain the address of the last node. So every time we will add into the next memory. Okay. So this last initially null, and initially we will also set this last equal to, because this is a first, this is a last node. Okay, so if we are adding first node, this condition will be satisfied, then we will set first equal to node, last equal to node. Okay, otherwise what we will do, we will just set the element last equal to sorry, last next equal to node, and we will set our last equal to node. Okay, so this is just a linking process. What we are doing, I'm just explaining here. So what we are doing here, so this first initially is empty. Okay, and after reading the first, data, we want to store the first information in our memory. So we are allocating some memory using the malloc function. Okay, we are at that so we will get one memory block that contains three fields: name, salary, and next. Okay, so that memory allocation will be provided for us, and at that time we will check this memory allocation is for the first node of the list. So at that time we will set first equal to this address. Okay, so we will just store the address of the first node in the first variable, that is a pointer. Okay, same things for the last, because this is the first node, this will also a last node. So we will also store the address of the same node in the last variable. Okay, so this is the first time. After that, suppose if we want to store the next information, after adding the first employee information, we want to add the second employee information. So that value should we add after this variable. Okay, so that's like this is the first way. Okay, this memory allocation is happen for second. So that means at that time, no need to set this first equal to second. Okay, because the first is only pointing to the memory block which contains the first employee information. After that, we will add into the end every time. After we will allocate the memory and we will insert into the end of the list. So at that time, what we will do, we will just set the information. So we will store the address of this here, okay, in next field, and we will also set this last equal to this value node. Okay, so this two operation we are performing in the, you can see that initially last is pointing to the first node. So what we are doing, last next. Okay, so we are just writing last, okay, and next. So last next means this location. If we are writing this last arrow next, that means we are just uh, pointing through this location, and equal to node. So this node is contain the address of the new node which is just created, and that address is assigning to this location. So that address is assigning to this location. Okay, and what we are doing, we are writing the next step last equal to node. So that means initially last contain the address of first block. After that we are writing this last equal to node. That means address of this current node, this last node will be stored into this last. So this last will be point to this node now. Okay, so in this manner we are just mapping this pointer in our code. So you can see that last next equal to node. Okay, after setting this, we are just assigning last equal to node. So this last will always contain the reference of the last node of the list, and this first will contain the reference of the first node only. Okay, so this happen only first time, but this operation will be performed after every time. Okay, after inserting in the every time. So this is the just empty node we have created and we have linked in our list. Now we have to fill the field. So because we are just storing the data, name and salary, we have to fill in this field. So what we will do, we will just read the value to value from the user. So scanf, and what are the value we have? First is the string and second is the salary. Okay, so first is the string for the name, and second we have for the salary. So that is int. Okay, and we will just write this value. How we can write? So because we are adding this, we are reading this value and we want to store this to information in our node. So you, what you can do, you can simply write node and this arrow sign. Okay, and what is the field of first name? Name. Okay, and similar for the next node and this salary. Okay, so these two value we are reading from the user. So what is the name and what is the salary? So okay, so this here we have to write this end symbol, but this is a pointer, so no need to write. Okay, this is representing a pointer of the string array. Yeah, so this, yeah. Okay, so now this is the first thing, and I think this part is done. Yes, so this is the part basically to create the list. Any doubt in this part? because we have just created the part to create the list. After that, we will perform the operation which is required for the problem according to the problem statement. So what is asking that? The problem is saying that uh, that dynamically allocate the memory with the employee record to create a list and the structure attribute, same things. And later, what is it is returning? Okay, this is just a definition. Read the employee name and salary separate by the specific structure and read the choices given. Okay, what is asking this problem? Oh, okay. So what we are doing, we are simply printing the no. Ah, okay. If more than one employee has the maximum salary, then print all employee names in the same order as they are inserted into the list. Yeah, okay. So here we are finding out the employee name which have the highest salary. Okay. So first we are storing this record in our memory. After that, we need to perform some operations. So operation is required that we will find out the name of the employees who have the highest salary. So now all the employee information is stored in our one list. So what we can do first, we can find out the maximum salary. Okay, so that operation we can perform first. So what you can do? Uh, okay, not this. Okay. Hmm. So I hope this part is clear. Any query in this part? Because now we have created the list. After that, we will simply access the data and we will just find out the max salary, and then we will find out the name of which have the max salary. So any doubt in this part? Anyone?
No, sir.
No, sir.
Okay.
No, sir.
Okay, so the next part is to find out the maximum salary. Because we have stored all the information in our list. Okay, so name and salary. Each node contains this name and salary for the each employee. So now we have to traverse the list completely and find out the what is the maximum salary. So first we just assign one variable like here. So int max equal to 0. Okay, so this is the initialization. After that, we just initialize with one pointer like this. So pointer should be the same type of this struct employee. Okay, so because we have to traverse the list, so like temp. Okay, this is one pointer asterisk, and we will initialize with first node. Okay, so first node first. This is the initialization. That means we have created one new temporary this temp variable, temp pointer, and that is initialized with the first node. Okay, so we have stored the address of the first node in this temp. After that, we will just run one loop while this temp does not equal to null. Okay. One more thing. Are we missing something? So, okay, one thing. Temp next, will temp next. Oh, okay. Okay, so after completion of this by choice. Yeah, one thing we have missed in this, because we are adding the node one by one, but last node next field should be null, and we have not stored null value in the last node in this code. So what we will do after completion of this process, okay, so this while process, so this last is actually contain the reference of the last node. So that finally what we will do, we will just store the null value in the last field. Otherwise, we cannot identify that which is the last node. So we will just store this information last equal to okay. Yeah, that we can do. Otherwise, we have this information of the last node in this last field. Still, we will just use this. So last dot not dot arrow dot next equal to null. Okay, so that next field we are just filling here because that maybe have some garbage value initially. So we are just filling this value inside the last next field. Okay, the remaining node next field we are filling here in the every time, but the last node we missed, so we are filling here. Okay, null. So we will just use this while temp does not equal to null. Okay, what we will do, we'll just compare this max salary by the each employee salary. So if that max is less than of the this temp. Okay, so this temp is pointing to the each node. So temp, we can write temp and salary. Okay, if this condition is true, then we will assign this max equal to temp salary. This is simple operation to finding out the max value in the all record. So salary. Okay, and after performing this, we will just move to the next node. So we will just write this temp equal to temp dot next. Okay, so this loop will run, and every time we will shift to the next node by this temp equal to temp next. Okay, and every time we will compare the max value. If max value is less than to the current temp salary, then we will assign max equal to temp salary. So in this way, so after completion of this while loop, so this max will contain the highest salary. Okay, so same things we will repeat again. This time we will print the node, the name of the employee which had the highest salary, because we know that temp one I'm taking here, and we will start first again. Okay, so temp does not equal to none. This time now we will compare the salary. Okay, equal to. If this condition is true, so this max is now contain the highest salary. If this max equal to current this temp one. Okay, let me update this temp one. So in this statement we print things. Okay, so print f percentile s, because this is the name, and here this is the temp one dash and name. Okay, so I think all is done. Yeah, so I hope this structure is clear. What we are doing, we are creating the same type of list. Okay, so it's a list. After that, in this part, after creating the list, that means we have stored all the data into the list. Then we are setting temp equal to first, and using this while loop, we are finding out the max salary. Okay, so we are comparing the salary with the max every time, and if we are getting the more salary with the previous max salary, then we are updating. Okay, so in this loop we will just traverse all the nodes. All the nodes means all the employee, and then we will find out the maximum salary amount. And after that we are performing the same operation again, but this time we are just comparing that which employee salary is equal to the max salary. Okay, and in this if this value is matched, then we are printing the name of that employee. So name, salary, next. Yeah, all fields are correct. So I hope this implementation is clear. So you can just perform the same things in the GRPA. Two questions are there to the related things. Let me check, maybe some syntax or error may be there. Oh, the big error is coming. So what error is there? Unknown name. Oh, strct. Still have this start. Start. Okay. TEM. Okay, this time is missed. Temp. Temp dot next. Oh, this one. This is a pointer. Okay, so this is giving the error like this. Okay, so we are using dot operator, but this is a pointer. So we cannot use this dot operator with this. Temp is a pointer. So I think one more place we have the same mistake. This one. Okay, so some. Okay. So we have to print this data into the new line character. Okay, so that is last thing. So let's. Now you can see that that all is matched. So I hope this things is clear with the dynamic memory allocation. So how we can do this, how we can store the data in our memory, and we can link the data.
Thank you, sir. It's clear.
Okay, so similar problem you can just solve in the graded GRPA. Any query? Any other problem in week 9? So this Friday, Saturday, we will start the week 10. So as I mentioned that OPP2 also contain the this week 10. Okay, so still week 10 syllabus is till week 10. So just complete the week 10 also before the 10th December. Okay, so that file related questions may be also there in the OPP. And regarding maybe I don't know. So all of you have completed this timed assignments on the proper time. Have you completed at least 2 timed mock, or anyone is missed this criteria for the OPP2?
Sir, I did not have proper email, sir. So I can't attend the timed program in correct way, sir.
So how many question you have solved approx?
Only 1 or 2, sir.
Oh. Okay, so we are just planning to discuss related these things. So some students are missed during some communication of these things. So maybe all students will allow in the OPP2 also. Okay, so that will be communicated by the mail or that announcement. So all students will be maybe allowed to the OPP2 without any this time mock criteria. So this is just under discussion. Okay, so you will get some announcement if this is
Sir,
final.
please consider my situation also, sir.
No, we are just thinking about for the all. Okay, so all can be participate in the OPP2. Okay.
Okay, sir.
Sir, when the OPT2 is scheduled, sir?
OPP2 is on 2 dates: 10th December and 17th December.
So any
Okay.
one date we can appear.
Sir,
Not yeah. So I think some form will be circulate to you, and first come first sub waste. That allocation
Sir,
will be
is there any
happen.
one date we can appear or both the dates we have?
No, one day, only one day.
Sir, actually, we got a mail regarding that we won't be having any introduction to C programming section in the quiz 2.
Yeah, quiz two. We don't have the quiz two for
Sir,
C.
so on what basis will they mark that, sir? Like, how is it?
No, that you can see the grading document. So what are the weightage for the each component? Quiz one, then OPP one, then OPP two. So at the place of quiz two, you have OPP one exam now.
Okay, okay.
So some percentage weightage is different for the C course. So you just check the grading document and check what is the formula actually for the marks.
So for then for the end term exam, we'll have it, right, sir? Like C
Yes,
program.
and we have end-term exam.
Okay, so they'll take the average between OPP 1 and 2, sir, for the quiz 2
No.
marking.
Both OPP one and OPP two have some separate weightage.
Okay,
Okay, I
okay.
think so. Overall, if you see the grading document, 50% marks is allocated for the programming part and 50% for the theory part. So I think 20% weightage is for OPP one, then 20% for the OPP two, 5% for the timed mock, and for that similar for the that graded programming assignment in this
Okay,
manner.
sir. Okay, sir.
Okay,
Understood,
so
sir.
50% theory and programming part, and 20% I think for this offline lab.
So
Okay,
20%.
that off-campus lab, some credit.
Okay,
Yeah.
okay. Yes, sir. Okay, sir. Understood.
Okay. So those who are coming on this 7 to 10th December slot in the campus, so just select the date 17th, okay? And those who are coming on the 14th to 17th, select the date this 10th December for the OPP exam.
Sir, for 7 to 10th, we should select 14th, sir,
No, we have two dates for the OPP to 10th and 17th.
of
Okay.
December, sir.
Yeah, December. For the same
Okay.
time, you have also two slots for the off-campus lab.
Yes, sir.
That
Yes, sir.
7 to 10th and 14 to 17th. So
Yes,
just
sir.
select accordingly. Okay, don't clash this.
Okay, sir. Understood.
Okay.
Sir,
Yes.
so I have chosen the slot 14 to 17th for that.
Hmm.
But sir, in 10 December, I have my train for IIT. So,
Sorry, in 10th December, what you have?
so my train is date on 10 December.
Why you are going too early on 10th?
Sir, in Varanasi, they have 10 December has a train.
Oh, then you will. Okay, so just check. Okay, so what we can do, because the OPP 10 first date is 10. So anyway, you have to give in the exam on one day, either on 10 or 17. So just check how you can handle this. Okay, so you can go after giving the exam on the 10th, then you can just depart. Or you can give on the 17th also, but that 17th date is actually included in the lab part. So that is the fourth day of the lab. So at that time, you have to take the permission for the prof. Yeah, the exam and that in that way. Okay, then any query or any discussion? If no query, then we can wind up the session. Okay. On Friday, we will just start the Big 10 content. Thanks, everyone.
Yeah, thank you, sir.
Thank you, sir.
Thank you.